Thanks. So no pressure there then. It's me or leftovers. Okay, so my name's John Adams. I'm the construction industry analyst at Autodesk. And over the next decade, we believe trends in technology are going to radically disrupt both the process of construction and the business of construction contracting by changing the way in which built assets are designed and made. So it's very much looking at the future now. Today I'm going to talk about this by addressing three topics. The nature of the disruption, that is, reshaping the transactions and interactions of consumers and producers of construction services. The implications of the disruption, how it's radically changing the way built assets are designed and made, and in so doing will change the industry. And finally, examples of what Autodesk and its customers are doing to manage this disruption. Now, Kaiman started with the Greeks earlier on, so I'm going to introduce the Romans. This is the Pantheon in Rome, built in the 2nd century AD. And whilst it's certainly a respectable example of building design, actually the most impressive feature is this: the largest unreinforced solid concrete dome in the world, weighing over 4,500 tons and with a diameter of over 40 meters. This was made possible by the disruptive innovation of Roman contractors who developed a new type of lightweight concrete using pumice. And it serves as an example of how technology has always disrupted the construction industry. Today, our view of how buildings and infrastructure are constructed and the associated business of contracting are both once again being disrupted. And the timing for this change couldn't be more pertinent. Construction is the progenitor to every other industry, underwriting the residential, social, and economic infrastructure of the global community. Over the next 20 years, population growth, urbanization, and economic expansion are set to underwrite a significant increase in demand. By 2025 alone, real industry output is forecast to rise to $15 trillion, 70% higher than 2012 levels. By 2035, the industry will have to solve the built environment challenge of tomorrow's cities, when around 2/3 of the 9 billion forecast population will be living in 600 cities. And all of that needs to be achieved against expectations of low carbon, low environmental impact, and low levels of waste and inefficiency. So much is going to be asked of this industry. And yet, this is an industry that for too long has been defined by the phrase high risk, low margin. An industry too often caught in the trap of low productivity, aggressive procurement, and a labour market routinely compromised by the boom and bust cycle. These rate challenges that we consistently hear all contractors face, regardless of whether they're a Tier 1 building firm, an industrial EPC, or a specialist trade. From maximising cash flow to improving bid success rates, from finding sufficient talent to competing in new, non-traditional markets. How well you navigate your way through this context, what strategies you deploy, and how you manage them is what determines how successful you are. And critically, we hear this is becoming increasingly difficult. But this new era of technology-enabled design and making is poised to disrupt the way your industry addresses these challenges. For contractors, it's going to deliver higher profits, greater resilience, and the ability to seize new opportunities as the market evolves. For stakeholders, it's going to deliver a better built environment, one that meets the aspirations of the global population. So let's delve into the nature of the disruption and what it means for the AEC industry, as it will help us better understand and prepare firms for the future. Today, we see three major technology-driven disruptions, catalyzing a new era for the construction industry. Changes in the means of production, how teams plan, design, create, and operate built assets, and how they explore the commercial implications of those decisions. Changes in the nature of demand, by which customers and consumers determine both the built asset's need and relevance, and the services required from the AEC industry. And changes in products, as devices, equipment, and systems deeply intertwine the physical and digital worlds. The means of intellectual production, how project teams undertake planning and design, and how commercial teams land on the most appropriate commercial strategy and contract terms is being disrupted. And at the same time, the means of physical production, how contractors create real-world assets, is also being radically changed. Cloud computing is allowing access to vast amounts of processing power on demand, known as infinite computing, which means the impact of even the most complex design or commercial change can be seen in near real time. Generative design takes it a step further, building the rules for design into an algorithm, letting the system harness that computing power to explore the infinite design possibilities and land on the best solution. Can you imagine using this when given 6 weeks to respond to an aggressive single-stage design and build engagement? Punch in the client specification, dial in your level of desired margin, contingency, and your supply chain partners, and watch as the options drop out before signing on the dotted line. Big data, you've heard that already mentioned a few times today, is a phrase most commonly associated with the finance and retail sectors. But now the construction industry is starting to capture large amounts of highly trustworthy information. And that's opening the door to what we're calling construction intelligence, the ability to predict the future by mining on that data. Consider how searching for patterns across a portfolio of current or historical projects might help you identify better strategies for material hedging, the best way to optimize cash flow, and the root cause for overestimations in your bids. Technology continues to shrink the boundaries between the physical and virtual worlds as well. High-fidelity modeling in immersive environments are going to enable teams to visualize in the context of the real world. Advances in reality capture are unlocking the potential to design in the context of the real world. Gaming technology supporting simulating in the context of the real world. And augmented reality supporting delivery in the context of the real world. So what might contractors do with such capabilities? One thing will be to use it to drive down the number of mistakes made in the real world. It's far cheaper to get it wrong virtually than in reality. Think of the boost this could deliver to construction productivity. But also, these kinds of environments might also help in responding to the boom and bust effect in the global talent pool. Could they provide a way to accelerate new recruits to acquire knowledge and become industry wise by learning in the context of the real world? And the cloud is also changing the very nature of work in a way that might uniquely mitigate one of the greatest challenges you face. How do you innovate and invest in people when, as an industry, you're so lightly capitalized? As the cloud brings us all closer together, it's bringing with it a range of new ways of connecting talent, from online exchange hubs to real-time collaboration environments to an app for pretty much anything. Can you imagine how this is going to reduce the pain of balancing books between the overhead of innovation and the need to run a lean operation? The means of physical production is also changing, as easier access to complex and off-site production methods is bringing cost and program down and pushing quality and value up. Prefabrication is becoming easier. Modeling technology is enabling contractors to work both from the bottom up, using optimized, standardized elements, and from the top down, in splitting an inherited design into elements that might be prefabricated off-site. This well-known example from China demonstrates the potential that prefabrication holds for helping the building industry achieve a high degree of standardization. But standardization isn't appropriate for every project or every component. And it's changes in another area of physical production that could be even more potent in disrupting how contractors deliver projects. The rise of additive manufacturing holds the promise of radically shortening the distance between a design and its real-world counterpart. One of industry's immutable laws has been complexity and uniqueness are expensive traits. It's cheaper to buy a standard component than make a bespoke one. But additive manufacturing technology is disrupting that law, going directly from a 3D model to a real-world artifact in a single touch, in a single machine, without having to retool, means complexity and uniqueness no longer have a cost premium. Here are two such examples: a 3D printed steel node by Arup and a 3D printed concrete house in China, available for a mere $5,000. The rise of microfactories is democratizing access to manufacturing capability, opening the door to a more efficient, collapsed supply chain for contractors with more choice, greater quality, and less overhead. And advances in automation in everything from drones to robotics offers the potential to improve safety and reduce the quantity of laborious, often dirty work associated with in-situ construction. The nature of demand for construction services and the nature of those services is going to be informed by, and in some cases, driven by advances in digital technology. First, let's look at the macro level. Most future demand is going to come from increasingly complex cities, the energy and resource infrastructure to support those cities, and within just 10 years, nearly 2/3 of demand for all construction output will come from today's emerging economies. But in such a high stakes, low margin industry, where and how should you respond? Increasingly, the answer is going to come from the big data. Trends in population demographics, economic growth, disposable income. All of this is going to be crunched by cloud computing to help contractors to answer that question. Now let's consider the micro level, the individual. Their preferences are changing, and that impacts contractors today, whether they'll be a user of a built asset you create or not. Consider how the rise of social media is enabling everyone to have their say in shaping our built environment. Whether it's the impact of a new highway in a crowded urban neighborhood or an offshore platform in the Arctic, the internet puts that project in everyone's living room, and that brings you an opportunity. Your social license to operate is going to be enhanced by engaging with the local community via this medium, to do everything from negotiating the best time for site deliveries, to perhaps offering local apprentice opportunities, to sharing environmental impact studies. Now let's consider the implications of what's happening with products as the real world and the digital world become deeply intertwined. Physical things are now deeply connected to each other and to other systems. This is opening the door to a new way of adding value to buildings and infrastructure and better aligning with your supply with demand across many dimensions. Occupancy levels, energy performance, water usage, passenger journeys, refinery throughput, much more. But move beyond the individual asset and seize the opportunity that this will support in building new relationships with your clients based on outcomes rather than price or even value. Think, for example, how this could help companies compete in the utilities sector, where many clients are facing a shift to tariffs based on TOTEX and outcomes-based regulation. Cisco estimates by 2020 there will be 50 billion devices connected to the internet, and that number will grow by 10 billion a year. Many will be smartphones, smart TVs, and other consumer electronics, but many more will be machines and sensors. Collectively, the data these devices produce could enable contractors to get better at forecasting future demand patterns at quite a granular level. Can you imagine how this will help mitigate uncertainty in project pipelines by identifying demand for services holistically? It's going to help enable companies to invest in talent and resources with more confidence. So changes in the means of production, changes in the nature of demand, changes in products. What will the net effect be? Simply this: the industry's relationship with its clients' assets, how it finances, plans, designs, and constructs them, how it thinks about them, will change radically. And so too will the very business of construction contracting. Why? Because those three disruptions are creating a new era of competition, one characterized by access to unlimited processing power to solve the most complex problems, seamless connection of talent across geographies and commercial interfaces to get the best ideas, intelligent connectivity within and between assets to deliver the best outcomes, and freer access to capital from reduced risk and alternative funding. And critically, these capabilities will be available to any company, regardless of size, type, or location. The barriers to access are going to be low. Autodesk is uniquely positioned to help the industry take advantage of these disruptions. Developing solutions and guiding the industry through technology-enabled change is something we've done through our 30-year history. We help the industry use digital technology to transition from manual processes, propelling it into the era of documentation, where CAD and computer-aided engineering platforms help to deliver enhanced workflows. We help the industry transition to digital modeling, propelling it into this current era of optimization, where models that simulate physical and performance characteristics are used to optimize a project, delivering enhanced outcomes. I mentioned earlier the challenges that we hear the industry faces. To address these, we're helping the industry move into this new era, where the underlying digital structure is one of interconnected systems, where project teams will maximize business outcomes by integrating all relevant context for a project, where physical-digital connectivity will support the best delivery of a project, and commercial teams will finally move the industry away from that high-risk, low-margin equation. So how might this change your business? Well, we'll just consider one example. The average margin for building projects amongst main contractors in the UK and Ireland is around 3 to 4%. One of the root causes for this modest margin is the difficulty in getting the commercial strategy right, particularly given the compressed timeframe contractors are expected to respond in. As a result, you take on risk and you reduce potential profit. Think how infinite computing is going to disrupt how you formulate commercial strategy for, let's say, a traditionally procured statement office building. Think of the myriad of contexts that you've traditionally had to juggle. The cloud is going to allow you to chew all of those up. Mining historic data and credit ratings might help you to better predict supply chain stress. Thank you. Identifying a customer's tendency to submit post-signing design changes might enable you to optimize your margins to be more competitive up front. Mining your current projects might enable you to load balance your vehicle movements, matching aggregate deliveries on one site with spoil removal on another. Analyzing the client's design might help you make a confident decision for the mix between prefabrication and on-site work. The net result is likely to be a far more confident strategy, one which strikes the right balance between price and risk for you and your client, gives greater certainty of the final margin, operating cash flow, and supply chain performance, and won't push you into a position of overtrading. And that's just one example. We're calling this the era of connection, and we're currently developing tools and guidance to transition the industry into this new era. And we're already seeing customers making the move. This is Hudson Yards, the largest private real estate development in US history, a multi-billion-dollar connected urban experience with unprecedented integration of occupants, buildings, transportation, utilities, and public space. 1.6 million square meters of mixed-use property over an active rail yard in Manhattan. It illustrates the era of connection because it's been designed and built from the ground up to be censored. It will be the first completely connected and quantified community with a comprehensive network of sensors, measuring, monitoring, modeling, and predicting energy use, transportation flows, waste recycling, air quality, and occupant health. This massive project necessitates the move into the era of connection, expanding on building information modeling optimization techniques to envision and predict based on data access and deeper systems understanding. Today we're seeing this era of connection unfolding across all the industries we serve, from manufacturing to buildings, from major capital infrastructure to blockbuster movies. Quite how this will develop in the construction sector is clearly still a work in progress, but the one certainty is that it will happen. Thanks for your time.